There we go. Alrighty, so you have negative 3x squared plus 18x minus 1. Okay, and they're asking us to put this in the transformation form. So that's what you're asking me, Maya, right? How we would rewrite this? Okay, so since this guy actually has that leading coefficient of -3, the first thing we actually have to do is take that -3 outside as our greatest common factor. But remember, you're only doing this from the first two terms. So that -1 at the end will stay as it is. So if we take the -3 outside, you would be left with x squared. Now, since this is a negative sign, basically if you think about it, you are taking this plus 18x, which is what you have. And since we're taking the -3 outside, that technically means you are dividing this middle term by -3 so that you can, bring it outside. So as you will see, when you simplify that, positive and negative will end up giving you -3. 18 goes into 3 6 times, so you would actually be left with -6 x when you take that -3 outside. So basically the idea is you're taking both your terms over here and dividing each one of these by -3 to get what you have inside the parentheses. Because remember, guys, for completing the square, your leading term, the x squared term, can only have a coefficient of +1. So we have to get rid of that -3. Now, once you get the x squared minus 6x inside the parentheses, then you can use completing the square on that. So for this guy, we would then take x squared minus 6x and figure out what needs to be added on. So just like we did in the example earlier, you take that 6 divided by 2 and square the entire thing. So remember, that would end up giving us 6 divided by 2 is 3. 3 squared is 9. So you would be adding 9 to complete your square, which means when you come back to your polynomial or your quadratic equation over here, you will have x squared minus 6x, and then we would add the 9 to complete the square. But again, remember, to maintain the balance, we would need to subtract the 9 at the same time. So you would subtract the 9 over here, and then we've got the -1 at the end. As far as completing the square goes, we only need these first 3 terms. So we don't really need that -9. So you will take this -9, multiply it with the -3 in the front, and bring it outside of the parentheses. So that means we would have -3. We only want to keep the first 3 terms. So x squared minus 6x plus 9 will stay inside. When we multiply -3 with -9, negative and negative becomes positive. 3 times 9, of course, is 27. And then the -1, just bring that down. So that's how you get rid of this -9, bring it outside. And then what you have left behind in the parentheses can now be factored. That should be a negative. So what does this guy factor into? X squared minus 6x plus 9. X minus 3. Very nice. So this becomes x minus 3 squared because, again, 2 numbers that multiply to give you 9, but add up to give you -6. So that would be -3 and -3. So that means -3 on the outside. This will factor into x minus 3, the quantity squared. And then at the end, you're just combining your 27 and -1. So that would, of course, add up to 26. So this is what your transformation form would end up looking like. Maya, does that help? Yeah, okay. Okay, what else did you guys have? This is interesting. Come on. Are you guys comfortable with a question like this? Trent can deliver his newspapers in 40 minutes. Lois takes 60 minutes for the same route. How long would it take them to deliver the paper if they work together? This is a work problem that we had seen in chapter 1.
Can you go over this one?
Yeah, sure, not a problem. Okay, so they're telling us, Trent is taking 40 minutes. So that's, trying to make sure I set this up correctly. So for Trent, again, the time T is time it will take them to work together. If Trent is taking 40 minutes, that means, his speed of work is going to be 1/40th, which means in 1 minute, he would have 1/40th of the work done. So this would sort of be his speed that he's working at. Lois, they're saying, is taking 60 minutes. So that means, her speed would be 1/60th, which means in 1 minute, she would have 1/60th of the work done. So the idea is you take their speeds and you multiply it by, the total time it would take them if they work together. So that's why when we set up these equations, it's T times 1/40, or basically you can write it as T/40. So that's for Trent. And then for Lois, it would be T times 1/60, which would come out to be T/60. And since they're doing one job, which is delivering the newspapers, you set this equal to 1. So basically you're taking the total time T, and then you're dividing it by 40, which is the speed for one person, and 60, which is the speed for the other person. So that's your equation. And in this case, I definitely recommend finding your least common denominator so that we can multiply our entire equation by the least common denominator. So between 40 and 60, what do you think the common denominator would be? And just think in terms of 4 and 6. Don't worry about the 40 and the 60. Just between 4 and 6, what do you think would be the least common denominator? Brandy, you're thinking the greatest common factor. Think about which number is large enough that both 4 and 6 can divide evenly into that number. Yeah, 12, very nice. So 12 would translate to 120 in this example because you've got zeros at the end. So basically take the entire equation, multiply by 120, which means each term multiplies by 120. So you would end up getting, 120 times T/40 plus 120 times T/60, and then, of course, 120 times 1 on the right-hand side. So, 4 goes into 12 3 times, so 40 would go into 120 3 times. 6 goes into 12 2 times, so 60 would go into 120, 2 times. So clean this up. And let's see, we would end up getting 3 times t plus 2 times t equals 120, which of course adds up to 5t. So what do you think the time comes out to be when you simplify this? So what do you get for your time over here? Let's see, Brandy, 24. So you would basically take 5 and divide it on both sides. And we are coming up with 24 minutes. And this is, of course, working together. Okay, and there you go. Okay. So remember, again, that is from chapter 1. Can you tell me which formula do you end up using over here? They're talking about how long does it take for a deposit of $600 to double at 1% compounded continuously. So I'm going to throw the two formulas at you and you tell me which one you're going to use in this example. Yeah, it's going to be the PERT formula with the E as your base. And you know that because they're specifically telling us that this thing is compounded continuously. So when it says compounded continuously, you are looking at the PERT formula. Okay, so can you tell me next, what are the, what information are you getting from your problem over here? So what's the principal dollar amount here? Very nice. Principal is $600 because they're telling you that's a deposit of 600. Okay, what's the R value, the rate of interest? Very nice. 1%, which will in decimals, Jack, very nice, will translate to 0.01. What's the time in this example? The t value. Yeah, because that's what they're asking you to find. They are saying how long does it take? Okay, so if t is the value we are finding, then that means what is the a value here? Brandy, very nice. Yeah, because they're telling you a deposit of 600 is going to double. So the double is, of course, going to be 600 multiplied by 2. So that's going to be the 1200. And then, you are finding the t. Alrighty, very good. So you've got 1200 equals, our principal is 600, e raised to the power of, let's see, the r is 0.01, and you are multiplying that by time t. Okay, so that means you go ahead and divide 600 because you're multiplying. 600 into e, you would divide, which would of course just end up giving you 2. And at this point, you're solving an exponential equation. So what would you do here to get your t value, the time? Because you basically have, if you think about this, you have a version of finding the t by itself. Yeah, you want to get t by itself. So what if you were given something like, I don't know, 2 to the x equals 5? How would you solve this? That's the same kind of thing they are asking you over here. So how would you solve something like this? What would you do? Very nice, Jack. Yeah, you need to either convert this into the logarithmic form or use your base change formula. Either way, it gets you to the same result. So remember, if you are given in the exponential form and you want to convert this to the logarithm, you would have log, same base a here. And then the y would go with the logarithm in this case. And then the x, being the exponent, would go on the outside. So when you convert this into a logarithm, now since this is a base e exponential function, remember you would have to use natural log over here. So you would basically have natural log of 2 equals the exponent, which is 0.01 t, or use the base change formula. And then, in this case, to get t by itself, you would just go ahead and divide by 0.01 and you would have your time. So convert your time into years and days. What do you come up with? Make sure you are using a natural log here. Don't use logarithm because that would be incorrect. Since your base was the natural number e, you have to use natural log. So in years and days, what will your time come out to be? Okay, so convert those, what do you get? How many years and how many days do we have? The 69.3147 doesn't tell us years and days. You have to break it down. $69 years is fine. Angelo, it's not going to be 31 days.
It'd be 32, wouldn't it? Because I have to round up.
Nope. The decimal is not the number of days. You have to convert that into days. Because the decimal 0.3147 is telling you it's 0.3147 of a year. Those are not days.
I multiply that 0.3147 by 0.01.
Nope.
Okay, I used to know how to do this. I'm trying to remember.
You're making it harder than it needs to be. Maya, so what did you do?
I did like the decimal part after the 69 and I times it by 365.
Very nice. Exactly what you need to do. Very good. So let me show you. And don't round your answer when you do the natural log of 2 divided by 0.01 because you would have 69 point, come on, bud. 3147, which is what Angelo had. But then after that, you have the 1806. Keep all of those decimals. So the 69 is going to be the number of years. So, go ahead and subtract the 69 from this whole decimal answer. So you would end up with 0.31471806. Keep all of those decimals and just multiply it by 365 because there's 365 days in a year, so that's why we're multiplying by 365. And then you can do the rounding, Angelo, that you were talking about. So this guy would then come out to be 114.872, and this one rounds up, like Maya and Brandy had, 215 days. So you've got 115 days, and then you've got the 69 years from that initial part. So you would put 69 over here, 115 over here. Okay, let's check that. You can see they're saying that's correct. Questions, guys? So, just be careful about which formula to use because there are those two different compound interest formulas. What about this one? You guys okay with this one? It's asking you for the degree of the polynomial, and then it wants to know what kind of roots does your polynomial have. So this is coming from chapter 3. The degree of the polynomial is a second degree. Very good. So that would be 2 over here. When you factor this, what kind of factors do you get? X squared minus 6x plus 9. X minus 3, yeah. And what kind of multiplicity would your root have over here? Very nice, yeah, because when you take that x minus 3, set it equal to 0, you would have x equals 3. But since this is raised to the second power, we would say this has multiplicity 2, which means you would actually go with option B, which says all roots have multiplicity 2, and you would say the roots are, I guess you just put positive 3 because it doesn't look like they're giving us any instructions on how to put the answer in. So then you're just putting the root is 3 and it has a multiplicity of 2. Okay, and that's all they want to know. So again, remember this was coming from chapter 3 where we talked about these multiplicities and roots and stuff like that. This is also coming from chapter 3. They are asking you to find the real and imaginary roots for this polynomial. So any idea on what we can do here to find the roots? Because remember, this is where we had talked about the rational zero theorem, Descartes' rule of signs, the upper bound, lower bound. So this was all from chapter 3. So if you saw this, what would you do? Go ahead, Maya.
Wouldn't you do synthetic division?
Okay, and then what would you divide it by? Because what number would you choose to do the synthetic division with? And Brandy, you said the same thing. Remember, that's where the idea of the rational zero theorem comes into play. So with the rational zero theorem, remember you take the factors of your constant term and divide it by the factors of your leading term, which in this case just happens to be 1. So if you look at factors of 14, you know, you would have 1 and 14 and 2 and 7. Since your leading term is just 1, you know, that would be factors of 1, which, you know, of course, just be the number 1 itself. So you would basically end up with 1 divided by 1, 14 divided by 1, 2 divided by 1, or 7 divided by 1, but we have to take into consideration positive and negative. So yeah, just start by dividing, you know, with positive and negative. I always start with 1 because, you know, if any of those numbers will work, it's always going to make your life easier. If they don't work, then I would probably move on to 2 and 7. Very rarely would that plus or minus 14 be the one that you need to try, because if you can find a zero remainder before that, then you know that, like I said, that makes our life a lot easier. So you can start by dividing by 1 if you like. So remember, your coefficients are going to be positive 1, minus 10, positive 23, negative 14, and make sure there are no missing terms, which we don't have any missing terms, because this is the third power, the second power, the first power, and the 0 power, so there are no missing terms. So can you tell me if we get a 0 remainder from this when you do the division? You do have a 0 remainder here, okay? So we bring down that 1 as it is. 1 times 1 is 1, which will give us what? Negative 9 over here. So that would be negative 9, and let's see, 23 minus 9 gives you positive 14, so very nice. 14 times 1 is 14, which gives you 0. So if 0 remainder, that means this guy is actually one of our factors, okay, or one of our roots, basically. So we should have for our zeros positive 1 in there. Now let's find the others. Remember, once you find that 0 remainder, just take your quotient and factor it out. So since this is a third degree polynomial, your quotient is going to be a second degree. So x squared minus 9 plus 14, and that should actually be minus 9x. So x squared minus 9x plus 14, what will this guy factor into? Brandy, very nice. Yeah, because 14, you're looking for two numbers that multiply to give you 14, but add up to negative 9. So that would be negative 7 and negative 2. So when you take each one of these equal to 0, you would get x equals positive 7, x equals positive 2. So those guys are actually also going to be your roots. This is a third degree polynomial. So at the maximum, you should have 3 roots, and that could be with or without including multiplicity. And in this case, of course, you have 3 distinct answers. So 1, 2, and 7. And you know, you can use the upper bound, lower bound, you know, the theorem on bounds to help you out. You can use your Descartes's rule of signs to help you out. So there are other theorems and rules that you can use to kind of help you narrow down some of these options. Okay, so let's check this answer and we are good to go. Now, just to remind you, if on the first try, like we did over here with positive 1 and you got a 0 remainder, you were good to go. But if you didn't get a 0 remainder, then my next option to try would have been -1. Then I would have moved on to +2, -2, +7, -7, that kind of thing. Okay, this is just asking you to read the graph to solve the inequality. So are you guys okay on this one? What would be your solution set for this equation over here? Or sorry, inequality, not equation. You are given x to the 4th plus 64 is greater than equal to 65 x squared, and they're asking you to solve the inequality by reading the graph. So what's the first thing you would do here? I would actually move that 65x squared to the other side, get 0 on one side. Remember, you always try to get 0 on one side of your inequality. So you would end up with x to the 4th minus 65x squared plus 64 is greater than equal to 0. Now you are solving this inequality. So what would be your solution set looking at the graph? Where is your inequality going to be greater than and equal to 0?
The first one be -infinity to -8.
Okay, very good. So this side, okay. And are you including or not including -8? Because look at your inequality symbol. It's greater than equal to.
Including them?
Very nice. Yeah, because of that equal to sign, you are including the endpoint. Okay, then what would be your other intervals here? Okay, let me see. Anna, Braden, you have -infinity to -8, and Braden looks like you are including them. Union, very nice. And then we are going, because that's going to be from here, right? Then we are looking at from these 2 points where it's going to be greater than 0 here again. So you're going from -1 to +1, including the endpoints, and then you pick right back up at +8, so including +8 to infinity. And Anna, looks like you meant to include them, right? With your curly brackets in there. Is that why you have those in there? Yeah, okay. Alrighty, so yeah, anything that is going to be above the x-axis is, remember, where you would have the positive value for your function, because technically when they say, x squared minus 65x squared plus 64 greater than 0, you can always think of that as, y values being greater than and equal to 0. So right here on the x-axis, it's equal to 0, and then above the x-axis, it's greater than 0. So that's why we're including our endpoints. Okay, very nice. So let's go ahead, plug this answer in. I'm just going to make this guy a bit smaller. Okay, so we are going from -infinity to -8, including that, union from -1 to +1, including that, union including 8 to +infinity. So hopefully you guys can kind of see that. And let's check this. And we are looking good. Okay, so again, just let the graph help you out. They're not asking you to solve this algebraically. I believe we had also talked about this example last time. This is about composition. So you can see this has x minus 5, which is coming from the g function. You have the third power. So that exponent of 3, you know, of course, is telling us it's this function. There's no absolute value in your capital H, which means you are not using the f function. So then you just have to decide, is it, you know, going to be option A because that's using G and H? Is it going to be option C, option E, or option F? I would probably start with these two and see if any of those would work before I move on to the ones with the 3 composition. So which one do you think would satisfy your equation for capital H over here? Part E or part F? And if it's neither one of those, then we'll move to the others. Katie, you're going with F. Okay, so let's take a look at that. That's G of H, which basically means that G is the outer function, H is the inside function. So if we have H on the inside, that's x to the third power. So x to the third will go inside of the G function, which means this x will be replaced by x to the third minus 5. And unfortunately, Maya, as you will see, this does not come out to be, or Katie, sorry, not Maya. Katie, this does not come out to be our h of x function, so it's actually not going to be f. So that means, you know, let's try for E and see what happens with E. So let's change the order. H on the outside, G on the inside. And inside G will be your x minus 5. So the x minus 5 will actually now replace the x in our h, the little h function. So that means you would have, you know, x to the third power, but instead of x, we are replacing it with x minus 5. And yeah, this guy definitely looks like the capital H function. So this order would work. This one does not. So it's going to be option E. So just do your compositions. And like I said, go with the simpler ones. If those don't work, then you can go with the 3 compositions. Since we were not using the F function, you will see we left out any of those options that had F in those, so we didn't worry about those at all. Okay, so let's do a check here. We are looking good. So it's going to be H of G in this case. So we had looked at this last time. You know, this is of course where you just plug in wherever you see the X in your function, replace that with P of 3. So everywhere that you have the X, so you would, and I'm not going to simplify this, I'll let you guys do this in practice, but everywhere that you see the X, replace it with this expression P plus 3. Here you would need to do FOIL first with the parentheses part. After you do the FOIL, and I'll just do a quick FOIL here to show you, then you would need to distribute these numbers inside the parentheses. Then simplify them. Okay, so just remember after you plug it in, you will need to do FOIL on this first part over here. I believe we had talked about this also, but do you have a question on this? Finding the center and the radius for a circle. Okay. And you know, of course, you can go and look at the lecture from last time to solve this inequality, what do you think you guys would do? B squared minus 6b minus 8 is less than 0. Can we try factoring with that? So remember, you have either the graphing method or the test point method. For the test points, you would need to know where your x-intercepts are. If you just think of this as an equation instead of an inequality, what would be your x-intercepts here? Do you have your intercepts? -2 and +4? Okay, because you're saying -2 and +4, that would multiply to give you -8, but it doesn't give you -6 when you add them. You know, that would add up to -2 instead of -6. And remember, you can always use the quadratic formula if you are not sure. So if you wanted to use the quadratic formula, remember it's -b plus or minus the square root of b squared minus 4ac divided by 2a. Because I would probably recommend using the test point method over here. So your negative b is -6 plus or minus, again, -6 squared minus 4 times a. A, of course, would be the coefficient 1 over here. C is going to be -8, and then divided by 2 times a, which again, a is 1. So when you clean this up, you would end up with, and that should actually be a 6, not a b over here. So that would give you +6 plus or minus -6 squared would give you 36. -4 and -8 would end up becoming positive. 4 times 8 is 32. And then you're dividing that by 2. So yeah, Maya, I just saw your question. So factoring actually is not going to work out in this case. And Katie, you got 3 plus or minus square root of 17. So let's take a look at that. This would add up to, let's see, 68 inside the radical. Divide by 2. So you would have 6 divided by 2 plus or minus square root of 68 divided by 2. And you can simplify that square root of 68 because 68 can be broken down into 4 times 7. Sorry, 17. And square root of 4, you know, of course, would come out to be 2. So then you would end up with 6 divided by 2 is 3. Plus or minus, you would end up here with, you know, 2 square root of 17. And then dividing that by 2 would just leave you with square root of 17 over here. So they're not happy numbers, you know, 3 plus or minus square root of 17. So 3 minus square root of 17 would go on the left-hand side. 3 plus square root of 17 would go on the right-hand side. If you need decimal approximations, 3 minus square root of 17 is about negative 1.12. And let's see, 3 plus square root of 17 is approximately 7.12. So you can kind of see that's where, you know, they have these numbers marked at in your graphs. You know, obviously they're confusing you by showing it to you like they look like 2 and 4 or, you know, sorry, 2 and 6 kind of thing. But, you know, obviously you can see what those approximate numbers would be. Now, remember with the test point method, the idea is that you choose test points from each interval, and then you see where you get your positive or negative y values from. Now, in this case, since you have your inequality as less than 0, we are interested in where your y values are going to be negative. So anything smaller than negative 1, you can use negative 2 over here. Something that falls between negative 1 and positive 7, so you can use 0 as your test point. And something larger than positive 7, you can use number 8 over here. So take each one of these test points, you know, plug it into your inequality over here and try and see, do you get a positive or a negative y value? So if we used negative 2 for our b value in your inequality here, that would give you negative 2 squared minus 6 times negative 2 minus 8. And what will that end up giving us? Are we going to get a positive or a negative value over here for this interval? So basically from negative infinity to 3 minus square root of 17, are we going to have a positive or a negative value in this interval when you solve this inequality or your expression, you know, with negative 2 as the b value? So what do we get over here? You get 8. Let's see, negative 2 squared would be positive 4, negative 6, minus 2 would be positive 12, minus 8, so that would be 16, minus 8, which would give us 8. All right, very nice, Anna. So this is actually giving you a positive value over here. Now the interval in the middle, which is using the test point as 0, so that would be 0 squared minus 6 times 0 minus 8. What will this give us, positive or negative? So the interval in the middle, what do we have? Negative 8, yeah, because these guys are zeros. So you're basically just left behind with -8. So we would have negative in the middle interval. And so that means we just have to check the last interval over here with +8. So that would be +8 squared minus 6 times 8 minus 8. What will this give us? Katie, +8, okay. So let's see, this one will give us 8 squared is 64 minus 4 times 8 is 42 minus 8. So yeah, technically we are subtracting what? Sorry, 48, not 42. Yeah, so that would end up giving us 8, which is again a positive number. So we are interested in less than, which means we were interested in negative. And for that negative, you will see it's the interval in the middle, which means your solution set is actually going to be between this interval. So your solution set, the way you would write this in interval notation, would be not including the endpoints, going from 3 minus square root of 17 to 3 plus square root of 17. So that's this interval right over here between our two x-intercepts. So 3 minus square root of 17, and then comma 3 plus square root of 17. So which graph would you choose? A, B, C, or D? And let me try and get some of that graph in your screen over here. So A, B, C, or D, which graph would you choose? Yeah, very nice, graph D, because that is going to be in between those endpoints. So yeah, very nice, Katie, Maya, Braden, good job. And again, we can do a quick check over here and you are good to go. So basically, guys, again, obviously we will not be able to do all 55 of these questions. You can see this is again coming from that same inequality concept. Now this one over here is coming from chapter 1 because this is a linear inequality, and this one of course is coming from the quadratic inequality. So that was, I believe, chapter 2, or it could possibly be chapter 3 also, but it's in one of those chapters over there. So you will have some questions on these inequalities. There will be a couple word problems like you saw with the compound inequality, sorry, not the compound, compounded continuously. You had the maximizing area problem that Brandy had asked us about, and then you saw the work problem in the practice exam. So just some of those application problems that we had talked about. So you have till midnight tomorrow to do any homework that you want to get caught up on, but also midnight till tomorrow to practice with the practice exam. And then those of you who are ready to take the exam, we'll be doing our exam again. That was Wednesday, December 2nd, so 2 days from today. And then I know, Mikhail, you said you were wanting to wait. So you have the option of taking the exam 9:15 on Wednesday. If you guys are free at 2:15 on Wednesday the 2nd, you can take it then. If you just wanted to give yourself a little extra time to practice, you have Thursday, December 3rd at 8 a.m., which is when my other class happens. So if you wanted to come and take your exam during that time, you would be okay. And then if not, then for you guys, the final time frame would be Monday, December 7th at the 9:15 time, which is the time for your class. If you are going to be taking the exam at a different time, which is not your class time, You do want to let me know, inform me ahead of time, because otherwise your exam will not open up if you don't tell me. So you have to let me know ahead of time when, if you're going to be taking it at the 2:15 or the Thursday 8 o'clock time. If you're doing this, Monday 9:15, Wednesday 9:15 time slot, you guys will be okay. All right, so just keep that in mind. Another thing I wanted to let you know while I have you here, for the final exam, I do need to see you. I cannot have, just the top half of your head or your hair or your walls showing up. If your screen is not going to be set right, I will not let you take the final exam. So please make sure I am able to look at you. John, even though technically you are in the screen, you are against a bright light. So I'm actually unable to look at you. So just make sure you're against, a wall instead of a window when you take your exam. So just, to make sure that we are maintaining that integrity for our final exam, just make sure I am able to look at you, your face, and you're not sitting against the light, so that way the shadow is falling on you. What other questions, guys, before I let you go?
How many questions is the final? I don't know if I've already asked this in the past.
So 25 questions, yeah.
Oh, that's
Normally
really
it's
not
30
bad.
questions, but we just don't have all the 30 questions in MyMathLab because some questions, we create on our own when we do it on a paper final, and we're not able to do that with MyMathLab, so you're down to 25 questions for the final. It will be comprehensive, so it will be from chapters 1 through 7. Go ahead, Maya.
So if you don't have a calculator, is it okay to use your phone's calculator?
Again, I'm not sure what kind of limitations a phone's calculator have. Some phones will have like a full scientific calculator, some don't. So it would honestly depend on your phone. But with phones, the problem is you have access to other stuff also. So we prefer you don't use a phone. If you can get you just a basic, simple scientific calculator, that would be better. But you decide on your own which is a better format for you. Because again, I honestly don't have any control on what kind of device you use since I'm not really there with you. So just make sure you have something which will let you do the calculations you need to do, and you won't get stuck if you don't have those options on your calculator. Okay, very good. What else?
We can use notes, and it is for 2 hours.
Yeah, you will have access to your notes. Like I said, if you can kind of create a cheat sheet for you, it would be easier. Because if you have to, flip through your notes and look for stuff, then you would be taking up time to do that. So if you have it easily available as a cheat sheet, that would help you guys just save time a little bit. Okay, very good. And make sure if you're using scratch paper, pen or pencil, the kind of calculator you want to use, just make sure you have all of that ready before you start taking the exam. So again, you're not having to go look for extra paper, or your pencil runs out, or whatever happens, you don't run into any of, just kind of like how you would come prepared in the classroom. Just make sure you have all of those things with you before you sit down to take your exam. Go ahead, Brandy.
You said it is 2 hours?
2 hours, yeah. Okay, what else, guys? Again, if you think of anything, shoot me an email, or I will have office hours starting at 1 o'clock. If something else pops up, you are welcome to come to other classes. So today at 2:15 and tomorrow at 8 o'clock, we are also reviewing in those classes. So if you something comes up and you wanted to come in and ask a question, you're welcome to do that, okay? Because we're reviewing with those classes also today and tomorrow. All right, everybody, if you don't have any questions, good luck. I will see you on Wednesday morning. So study hard and let me know if anything comes up you want to ask me any questions. So take care, be careful, and I will see you Wednesday morning.
All right, say Wednesday.
See ya. Bye-bye. Take care.